Imagine standing on a mountain so high that the air is thin and crisp. You are far away from city lights, surrounded only by the quiet hum of the wind. When you look up, the night sky is not just black with a few specks of light. Instead, it is a breathtaking blanket of glittering diamonds. The Milky Way galaxy stretches across the heavens like a vast, shimmering river of light, so clear you feel like you could almost reach out and touch it. This is the view from Cerro Pachon, a mountain peak rising nearly 9,000 feet into the sky in the remote Coquimbo region of northern Chile. It is a truly magical place. Astronomers travel from all over the world to come here. This is because the conditions for stargazing are nearly perfect. The high altitude means there is less of Earth's atmosphere to look through, so the stars don't twinkle as much. The air is incredibly dry, which means there are very few clouds to block the view. The region is also sparsely populated, so there is almost no light pollution to wash out the faint glow of distant galaxies. For scientists who want to study the universe, this pristine dark sky is a precious resource. It is like having the clearest window possible to look out into space and see its wonders. For these reasons, Cerro Pachon was chosen as the perfect home for a groundbreaking new observatory. This observatory is designed to see the universe in a way no one has ever seen it before. It sits on this special mountain, poised to open its eye to the cosmos and begin a decade-long quest for knowledge. The darkness here is not empty. It is full of secrets waiting to be discovered. Every star, every faint smudge of light is a piece of a giant puzzle. Scientists believe that by studying this sky from this unique vantage point, they can begin to put those pieces together and answer some of the biggest questions we have ever asked. From this high perch in the Andes, humanity is about to take its next great leap into the cosmic ocean. The quiet mountain is now home to a buzzing hub of science and engineering, all focused on one goal: to unlock the secrets of the universe. The clear Chilean sky is the canvas, and a powerful new telescope is the brush, ready to paint a new and incredibly detailed picture of our cosmos. The adventure is just beginning, and the view from here is absolutely spectacular. This mountain is not just a piece of land, it's a gateway to understanding everything that lies beyond our own small world. Perched atop this magnificent mountain is the Vera C. Rubin Observatory, a brand new facility that is changing the way we do astronomy. It is named after Vera C. Rubin, a pioneering astronomer whose work provided some of the first and most compelling evidence for the existence of dark matter. Her legacy of looking deeper and questioning what we think we know is the perfect inspiration for this observatory's mission. This place is not just another telescope, it is a marvel of modern science and engineering. A joint project between the United States National Science Foundation and the Department of Energy, built to conduct a survey of the sky on an unprecedented scale. Inside that dome is where the real magic happens. It houses a revolutionary telescope called the Simone Survey Telescope. This is not just a big telescope, it is a very special kind of telescope, designed to see a huge patch of the sky at once. But the true heart of the observatory is something even more amazing: the world's largest digital camera ever built for astronomy. This camera is about the size of a small car, weighs 3 tons, and is powerful enough to capture the entire southern sky in incredible detail every few nights. What makes the Rubin Observatory so different is its mission. Instead of focusing on one tiny spot in the sky for a long time, like many other large telescopes do, Rubin will do the opposite. It will scan the entire visible southern sky over and over again. Think of it like a security camera for the universe. It will take a snapshot of the sky, then move to the next patch and the next, until it has covered everything it can see. A few nights later, it will do it all over again. This constant scanning will create a massive collection of images, a treasure trove of data for scientists to explore. The observatory officially began its work in 2025, after years of careful construction and testing. The giant camera was installed in March 2025, and by June it was already capturing its first breathtaking images, proving that all the hard work had paid off. Now, as it prepares to begin its full scientific operations, a sense of excitement is building in the astronomy community. Scientists know that this powerful new eye on the universe will reveal things we have never seen before. It will find new objects, witness cosmic events as they happen, and help us create the most detailed map of the night sky ever made. The main job of the Vera C. Rubin Observatory is a 10-year mission called the Legacy Survey of Space and Time, or LSST. This is one of the most ambitious astronomical surveys ever attempted. The goal is simple but huge: to create a movie of the universe. For 10 years, the observatory will repeatedly photograph the entire southern sky, building up a deep and dynamic picture of the cosmos. Each night, it will take hundreds of pictures, and over the course of the survey, it will take more than 800 images of every single patch of the sky. This will allow scientists to see how things in space change over time. Think about how a movie is made. It is just a series of still pictures shown one after another very quickly, creating the illusion of motion. The LSST will do something similar, but on a cosmic scale and over a much longer period. By comparing images of the same part of the sky taken on different nights, weeks, or even years, astronomers can spot anything that has moved, brightened, or faded. This could be media group, real asteroid moving across starfield, telescope tracking asteroid path, animation of asteroid orbiting through solar system, photorealistic Eustocky distribute equally, an asteroid moving through our solar system, a star exploding as a supernova in a distant galaxy, or the gentle wobble of a star caused by an orbiting planet. The universe is not static, it is a dynamic and ever-changing place, and the LSST will capture that action like never before. The amount of information the survey will gather is mind-boggling. By the time it is finished, the LSST is expected to have detected and catalogued about 20 billion galaxies. That is more galaxies than there are people on Earth. It will also catalogue around 17 billion stars in our own Milky Way galaxy. This enormous catalogue will be like a new encyclopedia of the universe, providing data for generations of scientists to study. The survey will create the largest data set for optical astronomy in history, offering a deep, wide, and fast view of the night sky that will enable countless new discoveries. This cosmic movie will not just be for scientists. The data from the LSST will be made available to the public, allowing everyone to explore the universe from their own computers. The survey is a legacy for all of humanity. It represents a fundamental shift in how we observe the cosmos, moving from taking static portraits of the sky to creating a living, breathing chronicle of its evolution. For the first time, we will have a time-lapse view of the universe, watching media group real time-lapse video of galaxies merging, Hubble or Rubin images showing galaxy collision, computer screens showing galaxy interaction, photorealistic, stock distribute equally, galaxies collide, stars be born and die, and mysterious objects appear and disappear in the vast darkness of space. One of the biggest mysteries in all of science is that the stars, planets, and galaxies we can see make up only about 5% of the entire universe. The other 95% is made of two invisible ingredients: dark matter and dark energy. We know they exist because we can see their effects on the things we can see, but we do not know what they are. The Vera C. Rubin Observatory is designed to tackle this profound puzzle head-on by creating the most detailed map of dark matter ever made, and by precisely measuring the history of the universe's expansion, which is driven by dark energy. Dark matter is a mysterious substance that does not emit or reflect any light, which is why we cannot see it directly. However, it has gravity. This gravity pulls on stars and galaxies, making them move faster than they should. Vera Rubin, the observatory's namesake, was the one who discovered this. The LSST will map the distribution of dark matter by observing its gravitational effects on the light from distant galaxies. As light from these galaxies travels to us, its path is bent by the gravity of the dark matter it passes. This effect is called gravitational lensing, and by measuring the tiny distortions in the shapes of billions of galaxies, scientists can create a three-dimensional map of the invisible dark matter structure that holds the universe together. While dark matter's gravity pulls things together, dark energy does the opposite. It pushes everything apart. Scientists discovered in the late 1990s that the expansion of the universe is not slowing down as they expected, but is actually speeding up. Dark energy is the name we give to the mysterious force causing this accelerated expansion. The Rubin Observatory will study dark energy by measuring the distances to millions of supernovae and galaxies with incredible precision. By looking at how the universe has expanded over billions of years, astronomers can learn more about the properties of dark energy and how it has shaped the cosmos over time. By mapping the invisible 95% of the universe, the LSST could lead to a revolution in our understanding of physics. The data it collects will test our fundamental theories, like Einstein's theory of general relativity, on the largest possible scales. It might confirm our current ideas about dark matter and dark energy, or it might reveal something completely new and unexpected that forces us to rethink our entire model of the cosmos. The Rubin Observatory is not just looking at the stars, it is probing the very fabric of space-time, searching for clues that will help us finally understand the dark side of the universe. While the Rubin Observatory will look deep into the universe to study distant galaxies, it will also spend a lot of time looking at objects much closer to home. The LSST will conduct the most thorough inventory of our solar system ever performed. Because it will scan the sky so frequently, it is perfectly suited to finding small, faint objects moving against the background of stars. This includes everything from asteroids whizzing past Earth to icy bodies lurking in the far reaches of the solar system, far beyond the orbit of Neptune. This cosmic census will help us understand how our solar system formed and evolved. One of the most important jobs for the LSST is to help protect our planet by finding potentially hazardous asteroids. These are space rocks whose orbits bring them close to Earth. While the chances of a major impact are very small, the consequences could be devastating, so it is important to find as many of these objects as we can. It is estimated that in its first year alone, the LSST might identify about 129 new near-Earth object candidates every single night. Over its 10-year mission, it is expected to find tens of thousands of new asteroids, giving us a much more complete picture of any potential threats and plenty of time to track them. Beyond the asteroids, the survey will journey to the cold, dark outer edges of our solar system to study the Kuiper Belt. This is a region of icy bodies left over from the formation of the planets, and it is home to dwarf planets like Pluto. The LSST's sensitivity will allow it to detect thousands of new Kuiper Belt objects, some of which may be as small as a few miles across. Studying these pristine relics from the early solar system can tell us a lot about the building blocks of planets. Some scientists even hope the survey might find evidence of a large, undiscovered planet, sometimes called Planet 9, that may be hiding in the darkness. The LSST will even contribute to the search for life beyond Earth. It will be able to detect thousands of new exoplanets, planets orbiting other stars, by looking for the tiny dip in a star's light as a planet passes in front of it. It will also study the atmospheres of some of these planets for signs of molecules that could indicate life, like oxygen or methane. By mapping organic molecules in our own galaxy, it will help us understand the chemistry that leads to life. From protecting our planet to searching for new worlds, the Rubin Observatory is set to revolutionize our understanding of our own cosmic backyard. To conduct its ambitious survey of the sky, the Vera C Rubin Observatory relies on two incredible pieces of technology: the 8.4-meter Simony Survey Telescope and the 3.2 gigapixel LSST camera. The telescope itself is really a masterpiece of engineering designed for both speed and width. Unlike traditional telescopes that have a very narrow field of view, kind of like looking through a straw, the Simony telescope can actually see a huge patch of the sky at once. Its field of view is so wide that it could capture a portion of the sky more than 40 times the size of the full moon in a single shot. This is what allows it to survey the entire sky so quickly. The telescope achieves this wide view with a unique three-mirror design. Most large telescopes use just two mirrors, but Rubin uses a large primary mirror, a secondary mirror, and a third tertiary mirror, all working together to direct light to the camera with amazing clarity across the entire wide field. What is even more impressive is how fast the telescope can move. To scan the sky efficiently, it has to be able to slew from one position to the next and settle down in just a few seconds. This rapid repointing capability is absolutely essential for its mission to photograph the sky every few nights, ensuring no cosmic event is missed. At the heart of the telescope sits the LSST camera, which is actually the largest digital camera in the world. This is the instrument that will capture the light from the cosmos. Its sensor, called a focal plane, is made up of 189 individual sensors, all precisely arranged to create a single image with a staggering 3.2 gigapixels of resolution. That is so much detail that you would need more than 1,500 high-definition television screens to display just one of its images at full size. To keep the sensors working perfectly and reduce electronic noise, the camera's internal components are cooled to a chilly -100 degrees Celsius or -148 degrees Fahrenheit. This powerful combination of a wide, fast telescope and a giant sensitive camera is really what makes the Rubin Observatory a true discovery machine. Each night it will produce about 20 terabytes of data. That is actually more information than is contained in the entire print collection of the Library of Congress every single night. The camera's incredible sensitivity will allow it to detect objects that are 100 million times fainter than what the human eye can see. Together, these tools will provide an unprecedented view of the universe, capturing its faintest whispers and most fleeting moments with stunning clarity. Even before its official 10-year survey began, the Vera C. Rubin Observatory gave the world a tantalizing preview of its incredible capabilities. During its commissioning and testing phase in 2024 and 2025, engineers and astronomers pointed the telescope at a few well-known celestial objects to make sure everything was working correctly. The images they captured, known as first light images, were nothing short of spectacular. They immediately demonstrated the power of the observatory's wide field of view and the stunning detail its giant camera could capture, creating a huge wave of excitement for the full survey to come. One of the early targets was the Virgo cluster, a massive collection of thousands of galaxies located about 54 million light-years away. In a single snapshot, the Rubin Observatory captured a vast portion of this cluster, revealing not just the bright, large galaxies, but also countless fainter, smaller ones scattered across the frame. The image was so detailed that scientists could actually see faint streams of stars being pulled from galaxies as they merged and interacted with each other. It also captured bright foreground stars from our own Milky Way, all in the same shot, showcasing the observatory's incredible dynamic range. Another breathtaking test image was a composite view of the Triffidan Lagoon nebulae. These are famous stellar nurseries in our galaxy, regions where new stars are being born from giant clouds of gas and dust. By combining 678 separate exposures, the observatory produced an image of these nebulae with unprecedented depth and clarity. The picture revealed intricate details in the swirling clouds of glowing hydrogen gas and the dark, snaking lanes of cosmic dust. It was honestly like seeing these familiar objects for the very first time, with faint, wispy structures becoming clearly visible thanks to the camera's amazing sensitivity. These first images are just a tiny fraction of what the observatory will produce. One test run, combining over 1,100 images, captured about 10 million galaxies in one go. This is just a small taste of the 20 billion galaxies the full LSST is expected to catalogue. These early successes have proven that the telescope and camera are performing beautifully and are ready for their grand mission. They are a promise of the discoveries that lie ahead. If these test shots are this amazing, it is hard to even imagine the wonders that will be revealed once the 10-year cosmic movie officially begins to roll. The Vera C. Rubin Observatory will generate an amount of data that is almost too big to comprehend. Every night it will produce around 20 terabytes of data from the images it takes. Over its 10-year mission, the total amount of data will be hundreds of petabytes, that is hundreds of thousands of terabytes. If you tried to watch this much data as a high-definition movie, it would take you thousands of years. Sifting through this cosmic flood of information to find interesting objects and events is a challenge far too great for humans to handle on their own. This is where artificial intelligence and machine learning come in. Powerful computer algorithms will be the first to look at the data coming from the telescope in almost real time. These AI systems are trained to spot changes. They will compare each new image with older images of the same patch of sky and automatically flag anything that is different. This could be a new dot of light from a supernova that just exploded, or an asteroid that has moved. The system will then send out alerts, to astronomers around the world, within 60 seconds of an image being taken. This allows other telescopes to quickly turn and study these fleeting events in more detail before they disappear. Even with powerful AI, there is still a vital role for the human brain to play in this cosmic exploration. Our brains are incredibly good at recognizing patterns, something that can sometimes be difficult for computers. That is why the Rubin Observatory is partnering with citizen science projects like Zooniverse. These platforms will allow anyone, anywhere in the world, to help scientists analyze the data. You will be able to look at images from the survey and help classify galaxies, identify strange-looking objects, or track the light from variable stars. You do not need to be a professional astronomer to make a real discovery. This combination of cutting-edge technology and human curiosity is really at the heart of the Rubin Observatory's approach to science. By using AI to handle the massive scale of the data and empowering citizen scientists to explore it, we can make the most of this incredible resource. The discoveries from the LSST will not just be made by a few scientists in a lab. They will be made by a global community of explorers working together. This new era of astronomy is about collaboration, bringing together machine intelligence and human ingenuity to unlock the secrets of the universe for everyone. From the highest peaks of the Chilean Andes, the Vera C Rubin Observatory is opening a new chapter in our cosmic journey. For 10 years, it will watch the sky, patiently chronicling the lives of billions of stars and galaxies, mapping the invisible structures that hold our universe together and searching for our neighbors in the solar system. This is more than just a scientific project. It is an expression of one of humanity's most fundamental drives. The desire to explore, to understand, and to find our own place in the vastness of the cosmos. Exploring the universe helps us answer the biggest questions we can ask. Why is this exploration so important? Because it pushes the boundaries of our knowledge and our technology. Building the Rubin Observatory required inventing new technologies for telescope design, camera sensors, and data processing. These innovations often have benefits that extend far beyond astronomy, leading to advances in computing, material science, and engineering that can improve our lives here on Earth. Science is an engine of progress, and ambitious projects like the LSST are what fuel that engine, inspiring the next generation of scientists, engineers, and thinkers to dream big and solve difficult problems. Furthermore, understanding the universe gives us perspective. When we study the immense scale of the cosmos, the billions of galaxies each containing billions of stars, it reminds us of how precious and unique our own planet is. Learning about the violent events that shape the universe, like asteroid impacts and exploding stars, underscores the importance of protecting our own world. Astronomy connects us all. The night sky is a shared heritage for every person on Earth, and by studying it, we are learning the shared story of our cosmic origins. The Vera C Rubin Observatory stands as a testament to what we can achieve when we work together to pursue knowledge. It is a tool that will help us write the next chapter of our cosmic story, a story that is still unfolding. We do not know what incredible discoveries await us in the flood of data from the LSST. We might find answers to the mysteries of dark matter and dark energy, discover life on another world, or encounter phenomena so strange we have not even imagined them yet. But one thing is certain, what we learn will change our view of the universe and ourselves forever. The journey has just begun.